So we're nearing the end of the chapter. We're going to review geometric series today, and then we're going to do kind of an open-ended assignment tomorrow, and then we'll have a practice test. No. So I imagine on Wednesday you'll get your test review. We'll probably review 2 days, and we'll have a test on Friday. In Phoenix? Vegas? What are you doing in Vegas? They're totally going to card you. You're not going to make it in. No. Yes. You're what? Okay. Good idea. If Danny were to go into a casino, they wouldn't ask for her ID. They'd say, "I'm sorry, where's your mother?" Okay, we'll quit being mean to you, Danny. Okay. So there are 3 formulas you need when dealing with geometric series. The first one is the explicit formula, a sub n equals, do you remember what it is? A sub 1 times r to the n minus 1. Okay? Then there's the s sub n formula. This will find the sum for any finite series, which is a sub 1 times, no, oh boy, 1 minus r to the n over 1 minus r. That formula will be given to you on the test. Okay? Then sometimes you're allowed to plug in infinity. When are we allowed to find an infinite series? When r is less than 1, right. So this formula only applies in these cases. And somebody said something really valuable, when the numbers are going down, right? Or they could even go down and bounce back and forth between positives and negatives. So if you have like 0.8, that series would converge, meaning it adds up to a specific number. What does it mean for a series to diverge? It either goes to infinity, or it goes to negative infinity, or in a worst case, it bounces between positive and negative infinity. Because if your r value is negative, so if I had an r value of 2, then my sequence is going to look like this, right? Which means that my series is going to be, well, it's going to be even higher. Well, what if it's negative 1 times 2? Then it would look like this. Well, what if it's r equals negative 2? What does the sequence look like? It bounces back and forth, and it still diverges. It's going to diverge equally to infinity and negative infinity at the same time. Okay? But if the sequence approaches 0, so if my sequence gets smaller, or in this case, it could look like that. If my sequence gets smaller, then my series converges. So well, this doesn't exist. If I were to add this up, it would be here, and then here, and then a little bit higher, and eventually this graph is going to level off. The closer I get to 0, the closer this gets to some other value. Now, this converges. Let's do it this way. I built this thing for Leslie to use, and then I locked it on accident, so she couldn't use it. So, okay, so let's say that I had 8. That's my a sub 1, and I double it every time. Okay. So here is my sum, 8. My first term is 8. My second term is 16. And you can see the bigger this gets, the bigger that's going to get. But if I change this to, say, 0.8, now these numbers are getting smaller. So I'm at 33.29, and then I can continue this out. Oops, I missed. And these numbers are getting closer to 0. And this number is approaching, looks like 40. And I can actually go out until Excel gets tired. There. Now, Excel will only do out to 15 digits. And you can see here, it's at 40. Now, is that really the case? No. But Excel just got really tired and gave up. So watch this. If I delete back to 14, well, I probably have to go all the way to 13. So now it will be really, really close to 40. See that? So there's no way to get above 40. And in fact, the only way to get exactly 40 is to add them all up, all the way to infinity, which is impossible. But theoretically, we do that all the time. Okay? So what R values will make this some finite number? And the answer is any R value where these numbers approach 0. So if you have a common ratio between 1 and -1, a non-top heavy fraction, then every time you multiply it by your a sub 1, you're going to get closer to 0. And if your sequence approaches 0, your series approaches some other value. So that's what's really going on. Now, this is not the case for any series. For example, if I had the series 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, the sequence approaches 0, right? So a sub n approaches 0 as n gets big. But S sub n actually approaches infinity. It just does it very, very slowly. So when you get into higher math, Calc 2, I believe, it's not good enough that the sequence gets smaller. It has to get smaller fast enough in order to approach for S of n not to be infinity. Do you want a really bizarre answer? Sometimes, well, I'm just going to say this and not explain it. This can actually approach any number you want. If you want this to approach 7, then you can rearrange it so it approaches 7. Well, what you do is you take like this term and this term and this term, and you put those first. Well, you do like this one, this one, this one, that one. And then the next 3 spread out, and then this one. Then the next 3 spread out, and this one. And what you essentially do is you create a lot of sequences that approach 0 very slowly, and then you have one sequence that approaches 7. So it's basically 7 plus 0 plus 0 plus 0 plus 0. So it equals 7. And what you do is you spread these out really far. And that's all stuff you learn. I think it's Calc 2 when you get to that. We use infinite sequences all the time. Whenever we look at a situation that's too difficult to calculate using trig, or it's usually trig, but it could be anything. If an equation is really complicated, we say that's dumb, and then we turn it into an infinite polynomial. Like an x to the first plus an x to the second plus an x to the third plus an x to the n, all the way to infinity. And polynomials are way easier to deal with than other more complicated equations. You can do calculus, you can factor, you can do all these things that you can't do with other math. So what we do is we just build a computer, and this is all computers do. They take difficult situations and turn them into infinite sequences, which are extremely easy to use. And then a computer can't fit an infinite number, so we just go out far enough until we don't need to be that accurate. So like Excel went out to 15 decimal places and said that's good enough. So if you need 1,000,000 decimal places, that's fine. That's easy to do on a computer. So basically anything electronic has been turned into some portion of an infinite sequence. And we do it all the time. And calculus on polynomials, I've told you a little bit about this, is a cinch. It's so fast. So you could turn, the sine of the tangent of e to the x over 5 you can turn that into like something x squared plus something x to the third plus something, and that goes on forever up to x to the infinity, and then you just use how much of it you want. There are several different methods. That's a Calc 2 thing too, so we're not going to get there. Okay, so if r is between -1 and 1, then if I plug in infinity, then what is r to the infinity if r is less than 1? Well, let's look at it. Let's pick a fraction less than 1, like 1/3. Raise that to the infinity. What is 1 to the infinity? 1. What is 3 to the infinity? Infinity. What is 1 divided by infinity? Why? Well, you guys understand that 1 over 0 is infinity, right? How many zeros are there in 1? An infinite number. 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0, all the way up. Okay? Well, this one says, take a whole pie and cut it into how many pieces? Now, if I cut this into an infinite number of pieces, how big is each piece? 0. It's nothing but cuts, exactly. We do this. So can you see here how if I cut it so that some pieces were bigger than others, I could add this up to any number less than 1, right? So I could make my first cut like this, right? And then all my other infinity cuts go here. So this would be like 1/5. If I added them all up, I have a whole bunch of zeros and a 1/5. So I could cut this in such a way that the sum was anything from 0 to 1. Well, there are some sequences that sum to infinity, and if you cut them in the right ways and add up all the pieces, you have lots of zeros, and then whatever this is, and you can add that to whatever number you want. Now, why is that useful? I don't know. Yeah. Right. Unless you get to infinity. Practically, but can you see as n approaches infinity, as the number of cuts approaches infinity, the size of each piece approaches 0. Now, are we ever going to get there? No. But calculus allows us to say we can't get there, but we'll pretend like we can. So therefore, 1 over infinity is the number. What is 1 divided by infinity? 0. Now, I told you that some infinities are bigger than another, and apparently that quotes some really sappy teenage drama movie that I've never seen, that Travis has seen. Oh. Yeah, you're saying you probably watched it last night. So, consider this. I don't know what it's called. 2/3 raised to the infinity. What is 2 to the infinity? Infinity. What is 3 to the infinity? Infinity. What is 2/3 to the infinity? No. 0. Hold on. Don't let me lose you. Think about this for a second. Shh. This is less than 1, right? So if I were to graph this, here's 2/3. 2/3, well, anyway, 2/3, sorry, this would be 1. 2/3 to the first is 2/3. 2/3 to the second is 4/9, right? And this is going to keep going down. What is 2/3 to the infinity approaching? 0. But wait a minute. I thought infinity over infinity would be 1. Why is it 0? The top infinity is smaller than the bottom infinity, which is the equivalent of 1 over infinity. Well, 2 to the infinity grows slower than 3 to the infinity. So in this case, infinity over infinity is 0. Now, what if this was a 2? Then it would be 1. What if this was a 1? Then it would be infinity. So it just depends on how big your infinity is. Okay, back to the worksheet. So if I plug infinity in this formula, if r is less than 1, then this becomes 0, and I'm left with a sub 1 over 1 minus r. You're saying she's better than me? Okay, so now that I've thoroughly confused you, look at number 1. Yes. I'm mean. I'm a sadist. Next chapter. Okay. So, this says, evaluate the sum. Which sum formula will I use in this case? S sub n. Do I have everything I need to use the S sub n formula? Do I have a sub 1? Yes. Do I have r? Well, I can figure out r. It's 4. Do I have n? No. I know a sub n, but I don't know n. So how do I find n? Use the explicit formula. So 4096 equals 1 times 4 to the n minus 1. And I'm so mean, I haven't taught you how to do that yet. So you're going to go to your calc. You could guess and check. You could just go to your table and you see n equals 7. What does that tell me? No, it's actually the 7th term, if I plug in, would be 7 minus 1 is 6. So 4 to the 6th is 4096. So you can trust that n value. You don't need to treat it as an n minus 1 value. I know. I mean. Okay, so now I know n equals 7. Now I can use the S sub n formula. So S sub n is 1 times 1 minus 4 to the 7th over 1 minus 4. And then figure that out. If you look at number 7, no, I didn't want to save this. So look at number 7. We'll calculate 7 because this one's a little tricky. Do I know a sub 1? Yeah, it's -2. I could plug in 1, but if I plug in 1, then I get a 0 here, and 3 to the 0 is 1. So that is my a sub 1 term. Okay? All right, so -2 times 1 minus, what's my r value? So -3 raised to the 5th. Now, here's where people make a mistake. On the bottom, I can change it to 1 plus 3. On the top, can I change it to 1 plus 3 to the 5th? No. And more than that, Josie, Colette, is this a bad idea? Oh, okay. So put parentheses around that -3. So in your calculator, you want to type in -2 times 1 minus parenthesis -3 parenthesis raised to the 7th. And then close that parenthesis, and I'm just going to divide it by 4. So that is the sum. Okay? Now watch this. If I were to go 1 n further, so if I put an 8 there, what? That doesn't make any sense. R is negative, so this sequence bounces back and forth. which means that the series is also going to bounce back and forth because, well, only because it's growing. We just did 7. Oh, it's 5th. Sorry. I looked at the wrong place. So you guys don't know the answer. Yeah, don't plug in the number of the problem. That's a bad idea. Plug in the number that's right there. Okay. All right, so we now look at the backside, this other number 7. This is an infinite series. In an infinite series, what is the value of n? Infinity. Now, if n is infinity, it's going to add up to infinity or negative infinity unless the r value is between 1 and negative 1. Luckily, this one is, and in fact, I think they all are. So, with an infinite sum, you need an r between 1 and negative 1. You need your a sub 1 term, and you need your r value, and you don't care what n is because it's infinity. So we use the simpler formula, a sub 1 over 1 minus r, because that r to the n term got turned into a 0. So in this case, it's 1 divided by what is r? 1/3. So 1 divided by 1 minus 1/3. So we could plug that in our calculator. 1 minus 1 divided by 1/3. No, not minus. It's supposed to be divide. And I get 1.5. Does that really make any sense? Oh my goodness. I didn't. There we go. So if you look at this, this is 1 over 2/3. How many 2/3 are there in 1? Well, 2/3 and an additional 1/3, which is half of 2/3, so it's 1.5. So if you add all of these up all the way to infinity, the total is exactly 1.5. Because that sequence is shrinking fast enough, it's going to 0 fast enough that the series approaches a specific value. No. No, the only time you can make a sequence equal anything you want is when it diverges what we call conditionally. It goes to infinity, but it goes to infinity so slowly that you could rearrange it and create lots of zeros and then make it add up to whatever you wanted. Yeah. So you won't, I mean, that's way beyond the scope of this class. So look at 19. I love 19. It's a great problem. You're going to hate it. Okay. The height a ball bounces is less than the height of the previous bounce due to friction. In theory, if I were to drop a ball, how long would it bounce? Forever. But on Earth, friction kind of wins out and eventually it stops because bouncing balls aren't very efficient. So suppose a ball is dropped from a height of 4 feet and rebounds to 98% of the height of the previous bounce. Write the series in sigma notation. What is the total vertical distance traveled by the ball when it comes to rest? Yeah, this ball would have to be made out of a really special metal that would bounce on a really special metal. I'll have to see if I can find that video for you. But if you get the right metals that are elastic enough, you can get a ball to bounce what seems like to infinity. I'll see if I can find a video of it. So this is kind of tricky. What is the sequence going to be? So we're up here at 4 feet, and we're going to drop it, and the ball is going to bounce like this. Right? And we know that R equals 0.98. No, it's not. So let's add it up. 4 is the first height, plus 98% of 4, which is 3.92. Then what? No, not yet. Look at the picture. We actually have 2 of these, right? plus 3.92. And then we take 98% because it falls 4 feet, hits the ground, and then goes 3.92 feet up and 3.92 feet down. And then it's going to go up like 3.84 twice. So somehow you have to figure out how to add these up. And I'm not going to tell you how. There's a couple different ways to do it. Dang it. Cheater. Abe the cheater. So you could do it the way they did it, or you can split it into two sequences, have that be a sub n and sum that up, and have this be b sub n and sum those two up. That would also work. So we could have a sub n equal 4 plus 3.92 plus 3.84. Yes, and that's what they did on the answer sheet. Or you could do b sub n is 3.92 plus 3.84, and then you sum those two together. So there are several different ways you can do that. Or what Abe said was, well, I have two of these and two of these and two of those, so why don't I just sum up 3.92 plus 3.84, sum that up, and then take that whole thing and times it by 2, and then add an additional 4. Either way will work. But that kind of gives you a heads up on the next problem, which is a swinging pendulum. Okay. The pendulum works a little bit differently. When it says a pendulum swings, so the first one is 5 inches. That's so if we started here, that distance is 5 inches. And then when it comes back, it will be less than 5 inches. I don't know what you're talking about. Don't know. How does the solar system work? I got it. 42. Good luck.